After this process, this would be a fully furnished structure. This would be all our accreditations, different representatives from different countries that have visited us.
Welcome to the second segment of the Hydraform visit. I'm standing with Nathi Mdankwende, who is a technician at Hydraform, and he'll take us through the technology and also what Hydraform is, how we can actually get access to the technology, learn more about it, where to find them, how to find them, and the work that they've essentially done. If Nathi can take us through what Hydraform is, what the technology intends to do, and the work that you've generally done in the industry.
Thank you so much, Lirato. As you mentioned, my name is Nathi Mdankwende, sales executive as well as the account manager for different countries within the SADC regions, namely Namibia, Mozambique, Zimbabwe, as well as South Africa. So with Hydraform, normally people, whenever they see the name Hydraform, they just think we just provide brick making machines. And then the name itself, like Hydraform, stands for hydraulic formation. So meaning that the products that we do produce are formed by means of hydraulic pressure. So we don't just produce the machines that produce the blocks, but it's a turnkey solution to change livelihoods. If you listen to Mr. Gianni, our vision, the vision for the company, we don't just provide you with a building solution, but we transform lives as well. So we don't just build houses or build machines, but then we build skills, we build entrepreneurs, we build communities, we build livelihoods, we create jobs for people. We train people, we upskill individuals. Doesn't matter whether you're black, you're white, you're young, you're old, but what we do is we come with a turnkey solution to ensure that your project is a success, and then it changes your livelihood as a whole as well.
Let's go and see what this technology has in store for us.
Demonstration. So this one is our stationary, electrically operated interlocking machine. So you'd see the similarities for all our machines, all the blocks. That's what makes us different as well from our other competitors, whereby they produce the blocks horizontally, whereas ours are produced vertically up, so that the block itself, you ask about the durability of the block. So we have a certain height as well as certain length of the block, whereby we need the block to be about 230 millimeters, so that we still have that interlocking system. In between, how that actually plays a huge role is you'll see once the building is completed, all our blocks, since it interlocks, we never have any straight joints due to the size. That's why we compress our block vertically up. So our machines are very basic and any person can operate them. You've got your hopper, whereby the material comes in. We've got our compaction chamber. This is where the block gets produced. We've got our different sizes of our mold boxes, whereby this one is our 180, depending on which project. Maybe you're doing a single story housing, these ones can always be changed. You can use a 180 if you want a bigger size for your boundary walls, for your double story units. Make use of your 220 blocks, internal walls as well. So on the very same machine, you can produce different types so that you complete your project. The machines themselves, hydraulically operated, so with a pressure of about 3.5 tons, hydraulically operated. So as I mentioned, this one is electrically operated, so it's a 3-phase machine with a 2.2 kilowatt electrical motor. So what we're going to be doing is I'm going to be showing you the type of soil that we use. Please come this side. So we call this sandy loam soil. If you look at it, so it's free from organic matter, no grass, no roots. Now the magic happens here. So if you look at the soil, like the feel itself, it's a combination of smoothness as well as basically soapiness as well as grittiness. So the grittiness comes from the sand that's in the soil, so it's the natural properties, and then the soapiness would be the clay that is found in the soil. That's what offers the thermal properties of your block. That's why our structures are always cooler in summer as well as warmer in winter. Even our carbon footprint, we've got like low carbon footprint as opposed to your conventional bricks. For example, our blocks only has about 200 kilojoules versus your normal stock brick, which is sitting at about 1000. So coming back to Green Building Council of South Africa, it's what we're looking for. I mean, if you look at the 2030 agreement for net zero continent, that's what we're aiming for, like an indigenous technology that provides thermal properties, acoustic performance, water penetration, as well as durability and longevity. So we're going to be starting our machine. After this process, after producing the block, we take them to a curing bay whereby we cure the blocks for about 7 to 14 days, whereby we cover them with the 250 micron plastic, and then depending on the weather conditions, we would water them once or twice a day for a full 7 days so that the cement gains its optimum strength. Then that's when we would get our strength. So after 7 days, what we would get, we'd get about 60% of the final strength of the block. So according to the cement rule, is that cement reaches its optimum strength after 28 days. So ideally for a Hydraform block, if we're constructing a single-story unit, our minimum MPa that we work on the strength is 7 MPa. But if we're going to be producing our double-story units such as this one or your boundary walls, then we're looking at as a minimum strength of about 10 MPa. So which is like this block over here. Now, you asked Lerato another question on what sets us apart from the conventional range. So if you look here, I've got 2 stock bricks, which are commonly used in the construction industry. Now, if you look at our interlocking block here, which is our 220 mil block, it's equivalent to about 3 stock bricks. So instead of you constructing the internal wall separately and then the external wall separately, with Hydraform, you construct the internal and external wall simultaneously. So it's 38 blocks a square on the Hydraform unit, whereas on this one, the conventional range, it's about 50. So now this one is our material loading system, whereby you come with your wheelbarrow and then you load your material onto here. So this particular machine, since it's mobile, and normally we use it in rural areas whereby they don't have access to electrical power, and if you don't have enough labor to optimize your production, you don't have to manually mix. So it's integrated with a pan mixer. So what a pan mixer does is got 3 sets of arms. So it mixes your aggregates along with your cement. So after mixing, the material gets discharged to the side. So this is the engine. So it's got a double pump so that it powers the engine, it powers the pan mixer, it powers the compaction chamber. So this is an engine on its own, and then this would be a pan mixer. This is the frame, operated with hydraulic oil there, but it never really runs out. You can go for years without ever having to change it. You can go for more than 10 years without having to change your hydraulic oil, unless maybe there's a leak or the tank has been damaged. Then, similar to the electrical one, we've got a hopper that slides through very, very easily. The hopper fills the chamber with the material that you just produced. So it fills the exact amount of the material that is needed to produce a block. Then here, you've got your hydraulics, then your levers for operating. So this, your top cylinder, operates the bottom ram head as well as the bottom one. So this is what gives the block the top shape as well as the bottom shape. Then the bottom cylinder is the one that operates the bottom one. And then inside here, you've got wear plates for your sides, for the sides of the block. So completely, it makes an interlocking M7 M1 Super. So it's one of our best-selling machines. those ones, those blocks that you see over here were taken for ballistic testing. So we've got 55-gram full metal jacket for this one, which is a netto ball. And then this particular one, it's this one. It was an AK-47 API 123 GR armor piercing incendiary. And then that one over there was a netto AP 143 armor piercing. This so all those rounds, all those blocks were 7 MPa, and then the walls can resist a handgun. Your normal 9mm handgun, this can be resisted. So this is due to the clay's natural properties, whereby it expands and as well as contracts. So in the absence of water, in the presence of water, what it does is that it expands and then it fills all the voids. That's why you see, even when we produce the block itself, it's well compacted so much that there are no voids in between. So now, even with the thickness of the block, because we're looking at about 220 millimeters, so if you're to put in your finger here, you see you're only at the second ridge of the block itself. So that's why the bullet can't penetrate to the other side. So what we'll do, just to show you on the different finishes that you can do your Kilimanjaro finish. You can stack your blocks with the noses facing inwards. You can do with the noses facing outwards. You can do different designs that you would normally do with your conventional system. We've got this dome as well, so that you showcase that you're not just limited to flat structures, but then you can do radiuses as well. So when we did this one, we were using 3/4 interlocking blocks, no mortar in between. So if you get close, you'll see you can still see that there are gaps in between. Even the dome that you see that side, double-story units using 3/4 blocks interlocking. So it stood the test of time. For years, you were asking about durability, how long would the building last? And the nice thing about this particular building is in 2023, Boksburg was we're actually at the epicenter of an earthquake. But all our neighbors, if you look at the structures, if you're familiar with this area, they had to rebuild. But this building has remained intact. This looks like your typical, it's basically the size of your normal RDP units, which is about 40 squares. So we used about 2,700 blocks to construct this building, 11 days to construct. You can feel the thermal properties as you enter the building. It's cooler. Yeah. So there's a different finishes that you can do. You've got the varnish concrete as well as varnish treatment. You've got your normal backwash, your plaster, normal plaster. And then the nice thing, if you look here, the amount of plastering that you use when it comes to the interlocking system, only 2 millimeters versus that side, which is your conventional plastering. You don't need to plaster. You can tile directly on top of it. You can chase it for your electrical piping, because that's another question that most people don't understand, that how would we chase it? So you chase it the same way that you do with conventional bricks. So if you look this side, you'll see we're using a grinder when we're chasing, but look at the strength of the block itself. The grinder, you can tell the grinder was struggling to cut through due to the block strength as well. So now if you look at all these marks, the grinder was struggling. So it's thicker, plus it's stronger than your conventional blocks. Our technology moves with the times as well. So for example, on that machine, now we've got a double pump. Now the production has moved from 1,700 to about 2,400. We've got an automated skip loading system, whereby in the past it didn't have. Even since, as times are changing, people are looking at something that's going to be more automated. Unfortunately, I don't have it right now, but we've got what we call our M9, our M10 system, blockade system, whereby even remotely you can operate that machine. It's fully automated. You can even plug it and just see if the production is still happening. But only disadvantage with that would be your health and safety, because now you'd operate your machine on your laptop and you only find that maybe somebody else is close to the machine, then you end up injuring that person. But we are moving with the times. Like, there's lots of innovations, even not just on Hydraform itself, but then what we've done is we looking at other alternatives. For example, we would like our technology to be fully green. Instead of us just making our block being 90% soil, we would want it to be 90% organic, so that it reduces the cost of construction, because the biggest contributor would be cement. Even when it comes to ring beam, what we are looking at doing is introducing other things that we can make use of instead of your cement, so that our block becomes more affordable and more accessible. Because other countries, for example in Zim, they struggle when it comes to getting cement.